So this is very popularly known as NGE, which is also called as next greater element. So let us understand what it means. So NG is defined for all the elements of an array. It is defined for all the elements of an array. Now, what exactly is NGE? So let's say there is an array and there is some element called as, let's say, 7 at index I. There is some element at index I. Now there are two things in this, next as well as greater. So what is the meaning of next? Next means that everything which lies in the right side of it. So for finding next greater element of A of I, somebody tells me that, hey, tell me the next greater element of A of I. What I should do is, I must never consider anything which is lying to the back of I. I should only consider things that are lying to the front side of I, which is from I plus 1 to n minus 1. Now from I plus 1 to n minus 1, there can be many elements which are greater. Many elements which are greater, and by greater I mean strictly greater. So here I mean strictly greater, sometimes it can be relaxed also. So there can be many elements in the right side of ith element which are greater than it. So out of all of those, I want that element which is closest to it, okay, because next means exactly that. So let's say you have a 7 here, you have 6 here, you have 5, you have 9, you have 11, you have 0, you have 7, and you have 8. Can you tell me what will be the next greater for this 7? So in the right side of 7, which all elements happen to be greater than 7? Out of all the elements which are greater than 7, I want that element which is as close in terms of location, not in terms of magnitude, as close in terms of location. So see, 9 is greater, 11 is greater, and 8 is greater, but both of them are farther than this 9. So this 9 qualifies to be this next thing. So greater applies to all three, but next can only apply to the first of these three. So for 7, the next greater element is 9. So this way you can very easily get, okay, let us take another example. What is next greater element of 5? So immediately after 5 I see there is a 9 which is greater than 8, so that will be the answer. Okay, what is next greater element of 11? Let's say this is the last element, index n minus 1. What is the next greater element of 11? There is no next greater element at all. The question over here is formulated in this way, that I am going to give you an array containing elements like 4, 5, 2 and 25. And now you have to create an array called NGE. In this NGE array, for every element, whatever is the next greater, that should be written over here. So can you tell me how will the NGE array look like over here? So for 4, the next greater element is 5. For 5, 2 is smaller, 25 is greater, so 25 comes. For 2, it is 25. And for 25, it is nil. This is how the NGE of elements are basically defined. So what is the brute force way to solve this problem? Yes, 2 loops. Very good. So what you can do is, for every element, there are, if it is at index I, then there are n minus I candidates. So for I varying from 0 to n minus 1, your candidates vary from I plus 1 to n minus 1. Now you are interested in finding minimum value from I plus 1 to n minus 1. Sorry, not minimum value. Where is it? Out of all the values which are from j to n minus 1, you are interested only in the greater values, and out of all those greater values you are interested in just the next greater. So the moment you are traversing and you see that you get a value which is greater than this particular element, you can say that NG of that index is that element. So basically, if I write it, if I see that A of j happens to be strictly greater than I, then here itself I can declare that NGE of I is equals to A of j, and after that I must break. Why I must break? Because I do not want NGE to get updated to any other value. That also qualifies to be greater than A of I. Can I do it in a better way? See, Here what I was doing, I was fixing the element for which NGE is to be found. Listen to me very carefully. I was fixing the element for which NGE is to be found, and now I was iterating over all the possibilities. But here what he is saying, fix an element and then try to see that how many elements before it can assume this as their NGE. I repeat it again. Here you fix an element, but the moment you fix an element, you consider that as NGE of some other elements, and now those other elements will definitely be in the back. So iterate in the back and then see that how many elements are there which can have this thing as their NGE. Okay, can you think of an array where for every element the NGE is nil? Strictly decreasing array, or even elements can be equal also. So the array should not be increasing at any point. So let's say I have 5, 4, 3, 2, 1. Then NG of this is nil, nothing in right is greater, nothing in right is greater, nothing in right is greater, nothing in right is greater. And can I say that NG of last element will always be nil? So here if you apply that approach, what actually happens is, for this you iterate from here to here. 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 So don't you see that an element, let's say like 2, this has got touched multiple times. This got touched in the iteration of 5, this got touched in the iteration of 4, and this got touched in the iteration of 3 also. An element lying in the right is being touched in multiple iterations. So this is something that I want to prevent. Now let us understand how can I prevent this thing. Let's say there was another element also which was 7. If 7 came over here, can you tell me what will be the NG values for these 5, 4, 3, 2 and 1? Will all of them be 7? Yes or no? Yes, because for 5 the next letter is 7, and for all of them it is 7, 7, 7, 7, 7, 7, and for this it is nil. So did not you feel that if an element came over here which is, let's say, greater than this, so let's say this is AI and this is obviously AI plus 1. So if AI plus 1 is greater than AI, then definitely NGE of this will be this. Can I always say that? Yes or no? True? Right? But this thing doesn't just have mere potential to eat this, but this here has a potential to eat everything from here to here. So the moment this 7 came, it can just drive away all of these and declare that, hey, I am your NGE. And that is exactly what happened over here. So here this 7 happened to be luckily NGE of all of these. Let us take another example. Let us say I had something like 4.5. Can you tell me in this case it would have eaten up how many elements? How many elements this 4.5 would have eaten and said that, hey, I am your NGE? 4 elements, right? So if this scenario happens, then there will be a continuous streak of elements. There will be a continuous streak of elements that can be driven away by this 4.5. The streak can be 1, 2, 3, or it can be complete. So you can immediately get rid of all these elements and declare that 4.5 happens to be their NGE, right? But my question to you is, what kind of property should be there for this much of array so that it can sweep certain elements off and then stop sweeping beyond a point? So let us say you had 0 over here. Let us assume you had 0 over here. So in this case, let us say not 0, let us say you had something like this 5, and what if this was 4.7 or that? So basically I am trying to say, if the situation would have been something like that you had certain smaller elements than 5 over here, if you had certain smaller elements than 5 over here, okay, or instead of calling it something like this, call it, let us keep it calling 4.5, and let us keep calling this 50. So if let's say situation like this happened, that this thing is greater than certain elements in the back side of this also, if in the back side of this also, then what does that mean? That means that either their next greater will be this, either their next greater will be this if they are smaller than this also. But if they are greater than this, in that case their next greater will be this. A simple example could be something like this. Let's say this was something like 450. If it was something like 450, and then it was, let's say, 51. In that case, you would be tempted to say that, hey, the next greater of 51 should be 450. So the point is, if I somehow maintained that the elements are in sorted order, in decreasing order. So if the elements are in decreasing order, which was the case over here. So I had elements like 5, 4, 3, 2 and 1. And then the moment this situation happens, in the event of such situation, this thing can eat up from here and continue eating till the elements that it is getting are smaller than 4.5. And the moment it got something which is greater than 4.5, then because you have maintained it in decreasing order, everything before it will also be greater than 4.5. So 4.5 cannot be the next greater element. So what happened when this 4.5 came, this swept these off, and the moment this saw that now next element is greater than me, it also simply settled over here. Now again what you have is sorted in decreasing order. Okay, what should be the suitable data structure for implementing it according to you? Because the point over here was something like this, but I had 9754 and then I had 4.5. So with respect to this 4.5, I want to kick this out. Sorry. I had something like, let me redraw it. 5, 4, 3, 2, 1 and 4.5. So with respect to this 4.5, I want to kick this out, and kick this out, and I want this 4.5 to come over here. So what is the way to kick those elements out very easily? Can you do that in a simple array, or would you want to have some other data structure? Think of the last element as top of the stack. So if those last elements were the top of the stack, would it not be possible for me to get rid of them in order one time? Yeah. So that is exactly we are supposed to do. And I'll just try to show you how is that going to look like. Let's say my input was 10, 7, 4, 2, 9, 10, 11, 3 and 2. Okay. So I will start with an empty stack. Okay. And these elements, like here you saw a decreasing sequence that I was maintaining every time. That decreasing sequence will be there in the stack. From bottom to top, it will be decreasing. And the moment you see an element, you just compare it with the last element. The last element will always be the top of the stack. So whatever is your last element, that would either be the element before it in the array, or it would be something for which NGE has still not been calculated. Okay. So I always want to ensure that the elements in the stack are in decreasing order from bottom to top. So how do I initialize my stack? Can somebody tell me what should I initially put up in my stack? Guys, can I simply first push my first element, which is 10? Yes or no? I can push a single element very easily because the portion from here to here is sorted in decreasing order, right? Now what I can do is I move on to the next element. Okay. What will you do? You will compare it with the top of the stack. If this thing is smaller than top of the stack, can it sweep away certain elements? No. So what should you do? So whenever you compare it with the top of the stack and see that this is smaller or equal, you will simply push. Now you come here. What will you do? You compare 4 with the top. It is smaller, so you will push. Now you come here. 2 is smaller than top of the stack. You will push. Did you see that as a consequence of the rule that I have followed, my stack is in decreasing order from bottom to top? How many of you realize this now? Just type in yes quickly. Right? Now you will come to this 9. Now you come to this 9. Now what happens? This 9 is greater than this 2. Okay? So see, for convenience, I had written that at times when AI is greater than AI plus 1, that thing will happen. But it was not actually AI plus 1, it was the top of the stack. Now, it is not necessary that your top of the stack will always be AI minus 1 for AI. Sometimes it can be different also. Okay. However, let's take a look. Now here this 9 came and 9 is greater than 2. So can I say that it has a potential to not just pop 2 but many other elements also? Can I say that? Yes or no? Right? So what will you do? You will compare this with this. This is smaller. Yes. So you will say that the next greater of 2 is 9. You will get rid of 2. You will compare this with this. You will see that hey, 9 is greater than 4 also. you will get rid of this. Now you will compare with 7. So you will get rid of 7 also. At this point of time, what will you do? Now you compare this 9 with 10, what will you do? Can this 9 pop this 10? No, this cannot pop this 10. Okay, sometimes what can happen, let's say this thing was something like 8. If this thing was something like 8, then this 9 would have kicked out this 8 also, yes or no? It would have done that, right? In that case, your stack would have been empty. So now you are supposed to push this thing. So two things can happen. Either you emptied the entire streak. If you emptied the entire streak, you push it here. And if you could not empty it, if let's say you could just empty till here, then also just simply push it. So now you will have 10 and 9 over here. Now what happens? That now this thing comes over here. So now this is 10. So now again, I'll compare it with the top of the stack and I'll see that, hey, this thing happens to be greater than the top of the stack. So what should be done? So there is a streak that can be popped, okay, and that streak is just from top till top, from here till here. So for this 9, next greater will be 10, and now when I compare this 10 with 10, I feel that that 10 is not greater than it, so I should simply push it. So do you realize that every time the stack is sorted from bottom to top? Now you come to this 11. Now again you compare 11 with the top of the stack. What do you see? Is it greater? Yes. So this 11 can pop out many elements from the stack. Now did you realize that whatever is the top here, that is ai minus 1 for this. But after this an interesting case will come. So let's say you got rid of this 10 and you said that the next greater of 10 is 11. Now the top of the stack is 10, which was this. So this is very back of this, but still this 11 just came after it because of the nature of my algorithm. So this 11 can again pop this. So for this 10 also, next greater is 11. And now once again when this is empty, you will simply push this 11 over here. After this, what will happen? Tell me. When 3 comes, what will happen? You compare 3 with this, you see that, hey, 3 is smaller, so it cannot pop any elements. So you will simply push 3. And same thing will be done with 2 also. So did you get it? In the end, you will see that your algorithm has terminated. And now your stack contains these many elements. So what will you want to say about these elements which are left out in your stack and for which still you have not decided the answer? Can I say that the reason they are left stuck in the stack is because they do not have any next greater? Yes, right? So in the end, what you can do is you can pop these elements out and you can declare that, hey, their next greater is nothing but null. Cool. So now let's talk about implementation of this thing. Okay. So how do I exactly implement this? I was supposed to create an NGE array. Everyone look at it. People get confused but this is very simple. So what I want to keep track of the next greater of any element at that index in the NGE itself. I repeat, I want to keep track of the next greater of any element at that index itself in NGE. So I want 11 to appear here. Similarly, for 7, I want 9 to appear here. For 4, I want 9 here. For 2, I want 9 here. For 9, I want 10 here. For 10, I want 11 here. For 11, I want null, null, and null. So this is the output that I want to produce. Can you produce this output using the previous approach where you were pushing elements in the stack? It will not be doable, right? Because position in the stack, is it same as position in the array? Position of an element in the stack is not same as position of the element in the array, right? Because at times we saw that this 9, after getting rid of 2, 4 and 7 had come over here, okay? So when let's say this 10 comes and gets rid of this 9, you want this 10 to appear here at this index, not at the index 2 or something like that. Is there a very simple way to fix this, guys? So the first element that you pushed was 10. Do not just push 10, push 10 along with its index. And now whenever you push something, push that thing along with its index. Push that thing along with its index. Tell me one thing, if you know the index, this thing should be A of index only, no? So don't you think that it is redundant to push the value if you are pushing the index? So just pushing the index will also get my job done. What will be the time complexity of this? Why will it be order n? I have explained the complexities to such algorithms before. What is the maximum number of times you touch any element? 2 times. either while you are pushing it for the first time or you are popping it in the second time, right? So there will just be 2n iterations and not more than that. Okay, now how do I implement it? So I'm going to implement it by using a custom stack, and you also use your custom stack. You cannot build your own stack every time. Okay, so this stack is going to be a stack of elements, or is it going to be stack of indices? This is going to be stack of indices. So what will you push first in this stack? Can somebody tell me what will I push first? Yes, index of first element, and index of first element is index 0. So I'll do stack dot push 0. Now what will you do? Do you iterate on stack or do you iterate on array? Whenever you compare something, you compare the next element of array with the top element of the stack, right? So you already have this element placed in the stack. So now you will iterate from here and go till here, right? So now you'd start from I equals to 1 and you would go till n minus 1. Okay. How many of you feel I need a while loop inside this? Because let's take case of 9, to eliminate these many things, I need a while loop. So what would happen is that while I see that my current element, which is array of I, while I see that array I is greater than the top of the stack. So how should I write that statement? The top of the stack is not the element's value, it is element's index. So while array I is greater than array of stack dot top, so while array I is greater than array of stack dot top, till that time I can perform the process of popping and assigning their next greater. Okay, can something go wrong here? Can something go wrong here? You are calling a stack operation of top. Yes. What if this while loop completely emptied it and then you called a stack dot top? So in that case it will be underflow. And see guys, this is one of the most frequent runtime errors that some of you who don't abide by this will get, and such errors are considered very bad in interviews because your interviewer doesn't expect you to do things like null pointer exception or things like this underflows. Okay, so take care of that. So I should have a condition over here. So while not of stack dot empty, this is the method to check whether the stack is empty or not. This is a simple method. While not of stack is empty and array I is greater than array of stack dot top, till then I can do something. Is the condition clear to all? Yes or no? So till then what should I do? Till then I can say that next greater element of the top of the stack will be this array I. So next greater element of what? The stack contains the index. So I can write next greater element for stack dot top will be equal to array I. And after having done this, I'll do stack dot pop. What will you do when this while loop is over? So what did you do when set of numbers were removed, whichever could be removed? Yeah, the final thing will be to push this a of I. So the final line after the end of this while loop will be to perform a stack dot push a of I. Is that it? Can I say that after this I will have the next greater element of everything? Is it true to say? Yeah, I should push the index and not the element. Very good. I always push the index in the stack. Yeah, so is that it? So in the end it can happen that my stack contains certain elements, and it contains those certain elements because they did not have any next greater element. So when this for loop is over, you can write one more for loop like this, or while loop. So while not of stack dot empty, and for each of these you can say that the next greater of them is nothing but null. So you can say next greater element of the index stack dot top is nothing but null, and after this you can pop from the stack. So now this is a very important category of problem, and why this was done using stack, because I observed some things that whenever something comes which is greater, it can pop away many things. So I always have to remove something from the top of a data structure, and I always have to push something at the top of the data structure. So nothing better than stack can serve my purpose here. Okay, the way I have calculated next greater element, can you calculate next smaller element also? Is it right to say that if I calculate next greater from back, then that will make sense. Okay, so guys, can't you do it simply? Just think of it in this way. What you will do is, let's say you have an array like this, 10, 11, 12, and let's say then 9. So the stack that you have, you first push the first element, and here the order from bottom to top, should that be decreasing or should that be increasing to serve you better? That should be increasing, right? So what will you do whenever an element comes? If that element is greater than or equal to this, you will push it. Similarly, this is greater than or equals to this, you will push it. Now if let's say something smaller comes, let's say this was 8. Now if let's say something comes which is smaller than the top, so now you can pop till certain point of time. So you will pop these, assign their next smaller to be 9, and then push this 9. Now again you say that this is sorted. And trust me guys, this small little concept is extensively used.